As Director of Circular Economy Integration within the Corporate Innovation Department at Eastman, Jayme Leita is responsible for leading the development of capabilities required to deploy Eastman's advanced circular recycling technologies across the enterprise and into the marketplace. Leita has been with Eastman since 2003 and has worked in a variety of roles in technology, marketing, and business. His experience includes process improvement, technical service, product and market development, and platform management. He has played significant roles in the design, development, commercialization, and global market activation of 6 new products at Eastman. In his current role, Jayme is applying his experience to integrate the fundamentals of circularity into a platform of innovation for Eastman. Jayme is a chemical engineer from Tennessee Technological University and is also a certified Six Sigma Black Belt. Leita lives in Johnson City, Tennessee with his wife, Molly, 2 children, and family dogs. Jayme, the floor is yours.
Can you guys hear me?
Perfectly.
Awesome. Thank you, Jayme, for that great introduction, and especially thanks to Carrie. What an inspiring story and a great company there. Having several kids and pets, I'm anxious to go try out her products. So what a great story there. So I don't know about you guys, but between adjusting to working from home on top of homeschooling and feeding a 9-year-old and 12-year-old, it's been a pretty busy time. So I want to start out by thanking everybody for joining us here this morning. Really appreciate it. Especially thanks to SPE for quickly pulling off this virtual version of Antec. I've been really enjoying the proceedings and especially the format. I think this works out really well. It's been great to experience it. So even though I was really looking forward to going to San Antonio and enjoying Mexican food on the Riverwalk, this format is working out great given our circumstances. So I'm really excited today to talk to you guys about revolutionizing materials right now in the context of the circular economy. All right. For those of you that don't know Eastman, we are a global specialty materials company founded exactly 100 years ago. We're celebrating our 100-year anniversary here in 2020. Perhaps the most important thing to know about Eastman is that we are driven by a singular purpose, and that is to enhance the quality of life in a material way. That purpose has led us down an innovation path that has created material solutions to some of the world's most challenging problems, from feeding a growing population to meeting the demands of a growing middle class. And you can see from the pictures here, most of our focus has been on durable products or advanced material solutions. We believe that the plastics industry is at a critical juncture, and we have to demonstrate a viable path to circular solutions, and we must do it now. And that's what I really want to spend time talking about today. So, as I just shared, Eastman's purpose is to improve the quality of life in a material way. The unfortunate reality of that is that the world has at least 3 very real challenges that could impact the quality of life. First, we need to quickly and efficiently feed and care a global population quickly reaching 10 billion. Secondly, our climate is changing, and there's a host of potential consequences associated with that. And thirdly, the world has a plastics waste problem. So China stopped taking the world's waste in 2018 and called it national sword. Much of the developing world has severely insufficient waste management systems. And when waste is collected, it often goes to unmanaged dumps that are frequently emptied by tsunamis and typhoons. Bali, Indonesia, and other island countries are overwhelming with plastic waste. much of which makes it into streams, rivers, and oceans. Most are unable to manage their own waste, much less the waste collected in the developed world. Leading the way in solving the plastic waste problem is the Ellen MacArthur Foundation. Hopefully many of you have heard of them. They are an NGO serving as a catalyst to change and have established themselves as critical to solving circularity. They're practical and capable. They've been able to bring together corporations, governments, universities, cities, and consumers towards a common goal of creating a circular economy. In my opinion, they are literally changing the world. If you haven't checked it out yet, Ellen MacArthur herself has a series of 3 podcasts. Each one's about 20 minutes, and it's about the circular economy. And I highly recommend you check those out. Very, very good. The Ellen MacArthur Foundation has taken a broad, systemic approach to enabling circularity, and they've created a ton of momentum. So to be part of the solution, Eastman joined CE 100 in early 2019, where we work together with other organizations to problem solve and collaborate on transitioning to a circular economy. So one great example that has come out of CE 100 is the white paper on mass balance, outlining its importance and effectiveness in enabling a circular economy. Eastman's very proud to have 2 people that contributed to that landmark publication. Ellen MacArthur also hosts 2 other initiatives, Make Fashion Circular and the New Plastics Economy, both of which Eastman is thinking about joining. So to join the New Plastics Economy, we're going to have to sign or be signatories of the global commitment and set ambitious targets for the amount of recycled content in our plastics by 2025. And we will not be the first company to do that. As a matter of fact, over 450 major brands, retailers, and organizations have signed. By doing this, they are committing to eliminating the plastic we don't need by innovating the plastics we do need to be 100% reusable, recyclable, or compostable, and to circulate all the plastic we use through bold and aggressive recycled content goals. So the few companies shown here on this slide have committed to at least 25% recycled content by 2025. We think this is going to be very, very hard. However, it will drive a recycling revolution in the plastics industry that everyone on this broadcast should be super exciting. As a plastics professional, I think this wave is coming. It'll be a great thing for the industry. So at Eastman, we plan to serve a critical role in enabling these bold commitments by enabling high recycled content while doing it with lower greenhouse gas emissions. All right. So we're gonna, now that I've framed up the challenge, we're gonna try a little bit something interactive here, and we're gonna do a poll. So what I like to do is gauge the audience's confidence in the plastics industry being able to meet these challenging recycle goals. So first, let's go ahead and set the poll up. So everybody go ahead and grab their phone. And we're using this separate software rather than the Zoom poll because we want folks on the YouTube live broadcast to be able to participate. So grab your phone and text to the number 22333, text the word EMN poll, and it should go ahead and give you a message and let you know that you're set up. So Jayme, let me know when you're ready, and we'll use you as a proxy for the audience.
All right, I'm trying right now. EMN poll gone.
Okay. So, how quickly will the plastics industry be able to deliver material solutions with greater than 90% recycled content? If you think it's 5 years, go ahead and text A on your phone. If you think it's 3 years, text B. And if you think it's C, or right now, type, go ahead and do C. And we can watch the results come in live here.
All right, for the 3,000 and so people that are in the audience, right? Come on, guys, get your phone out. It's not so difficult. Well, votes are coming in. You got about 30 responses right now, 25. All right, we'll just leave it for a few more seconds.
Yep. Oh, there we go.
People still voting. So how quickly will the plastics industry be able to deliver material solutions with greater than 90% recycle time? I'm getting a message here that how come you don't have a number greater than 5, but that's okay.
Just the type of feedback we're looking for.
Right.
All right. So as the numbers roll in, first of all, thanks everybody for participating. Pretty much the data suggests that it's going to be further out there, at least 5 years. So I'd like to talk to you today about how that's happening right now and give you a little bit of detail around that. All right, let me switch back here. Okay. So again, I'm going to talk to you about how that's happening right now and back that up with some data and some results. So lost in the debate that plastics are evil, is the innovation that plastics packaging has been instrumental to improving the quality of life. Plastics are pivotal in hydrating, feeding, and caring for the planet. So a huge number of people still don't have access to clean drinking water. Plastics continue to make this possible. Plastics enable us to feed a growing population while reducing spoilage, which is a major contributor to greenhouse gas emissions. And of course, especially during times like such as now, plastics have been critical to innovation in medical devices and driving down the costs of healthcare. I could go on and on talking about what the plastic industry has done to helping shape the world to be a better place. Just one example is the plastics industry. Probably many folks on this call has done a great job in reducing the amount of material in packaging in general. And down gauging has been a major theme in the last several years. And just innovations like things like this water bottle that reduce the amount of single-use packaging. So most would not debate any of these points. However, they would say, yes, but what about the end of life? So this brings us back to the plastic waste problem that I was talking about earlier. So let me bring that to life for you a little bit. So of the 300 million metric tons of plastic that's produced globally each year, 260 million metric tons are disposed. And of that plastic waste, 40% ends up in landfills, 25% is incinerated, and most alarmingly, almost 20% of that ends up in the environment. So most of this is the stuff that gets swept into streams, rivers, and oceans. Only 16% of the plastics disposed actually gets collected for mechanical recycling, and only 12% of that original 260 million metric tons actually ends up getting mechanically recycled in the United States. So once you digest these numbers, it's not hard to see quantitatively why we have a plastics waste problem. So this fact is driving a number of legislative bodies and NGOs to call for bans on single-use plastic. Last time I looked, some form of single-use plastic was banned in 27 countries, now including China since early this year. So these proposals may seem radical to the folks on this broadcast, but the reality is they're understandable given the magnitude of the waste issue. So, however, the reality is we don't just have a plastic waste problem, we also have a major challenge in climate change. The data is becoming overwhelming that climate change is occurring. Public concern and conversation about its impact on our ecosystem has increased exponentially. So according to a recent Pew research study, 52% of Americans rate climate change as a top priority. And 3 years ago, that number was only 14%. So it's rising. So as we innovate in the plastic industry, we need to address both of these. We can't just look at the plastic waste problem alone or the climate change problem as alone. So I'm confident that as an industry, we can shift the conversation from a yes, but to a yes, and. Yes, the world has serious needs that plastics play an indispensable role in meeting, and we know how to solve the waste problem that comes along with using plastics. So, how do we do that? The solution to the plastic waste problem is nothing new. It's been around for almost 50 years, born out of the Resource Conservation and Recovery Act of 1976. We need to simply fully deliver on this guidance. The first was reduce. We got to continue to reduce wherever possible. The plastics industry has led the way here by designing polymers and additives that enable down gauging, as I mentioned before. Brands and retailers have reduced the amount of packaging overall. This is not enough. We got to keep pushing the boundaries on reduction. And frankly, the inconvenient truth is we all need to reduce our personal consumption. We got to continue to innovate solutions that drive reuse. So there are lots of examples. So for example, today, reusable water bottles are an area that has experienced rapid growth and eliminated lots of single-use packaging. Things like this food storage container has addressed food safety concerns as well as improving dishwasher safety or dishwasher durability that have enabled the preservation of food. So there's been a lot of progress in the first two R's, reduce and reuse. However, the real and pressing need is to increase the useful life of materials through a fundamental step change in recycling. And this is what I want to talk about is happening right now. So I'm going to bring you back to this slide, which I showed earlier, and remind you of the bold recycle commitments that brands and retailers are making. And point out that these commitments are impossible with mechanical recycling alone. And what do I mean by that also bold statement? So let me show you some data. All right, so over here on the left, you can see the 7 types of resin identification codes or RICs. Most people on this broadcast are familiar with these as they're many plastics engineers. What you can see on the right is that most plastics are simply not effectively mechanically recycled. There are only 2 widely recycled plastics, PET and high density polyethylene. And this is generally your clear PET bottles and your natural high density polyethylene milk jugs. They both enjoy mechanical recycle rates of around 30%, which is impressive, which is good. But beyond that, most other plastics just don't get mechanically recycled due to the difficulty or cost associated, not to mention the lack of collection infrastructure. And then even when plastics are mechanically recycled, they're often downcycled into lower value products. For example, green PET gets recycled into strapping or banding that's used in the logistics industry, in the shipping and handling industry. So I want to make something very clear. I'm not here today to disparage mechanical recycling in any way. I'm just saying it's not enough to meet the goals for circularity. We need something more. So what is that? When people say made with recycled content, that has historically meant mechanical recycling. However, as we innovate and create new chemical recycling technologies, there's always this debate, which is better, mechanical or chemical? And the reality should not be mechanical versus chemical recycling. It should be mechanical and chemical recycling. So let's start with mechanical. Mechanical recycling, absolutely most efficient and environmentally friendly recycling process. Cleaning, chopping, and remelting takes far less energy than any other recycling process, thus it has an optimum greenhouse footprint. However, it is limited to a few clean sources that it can use, and as I showed you on the last slide, and it often results in reduced performance of key properties. So there's only a certain amount of mechanical recycled content that you can put perhaps into a PET bottle before the color starts changing or the mechanical properties start to degrade. And there's only a certain number of times you can mechanically recycle something, because every time it goes through that heat history, the properties degrade a little bit. So let's now compare that to chemical recycling. But first, let me say there's a wide variety of different types of chemical recycling technologies. And want to be very clear that at Eastman, we believe these technologies should only be deployed when the carbon footprint is superior to the comparable process using fossil feedstock. So don't go out and chemically recycle when you're actually creating a worse carbon footprint. So when you do chemically recycle, the great news is you can use a broad range of plastic waste. And when you do take the product, take that plastic either down to the monomers that originally made it or the molecules that it came from, those molecules and monomers are indistinguishable from monomers and molecules that came from fossil feedstocks. And then of course, with chemical recycling, you can do it over and over and over again. So to recap, mechanical recycling is the best choice if the applications allow, but whenever mechanical recycling doesn't work, or you need higher content, or you need infinite recyclability, chemical recycling is a great option. Okay, so what is chemical recycling? Well, it's not a single technology or a single process, but at Eastman, we think chemical recycling should only be used for material to material solutions, much like mechanical recycling. In this way, it keeps the carbon in play forever. So we prefer chemical recycling that's circular, unlike waste to energy or waste to fuel solutions. So chemically recycling plastics that are then used to make fuels or energy, that energy is used up, and you have to replace the plastics that you recycled again by pulling them out of the ground. So we prefer keeping that carbon in play all the time. So let's talk about the two very high level types of chemical recycling. In the first type, you can take a broad mixture of different types of plastic, break it down to the molecules or small hydrocarbon chains, and convert those into a range of products. So examples of this are pyrolysis, reforming, anaerobic conversion, these types. The second type are more plastic family focused. So you have a homogeneous waste stream where you unzip the polymer back down to its basic monomers. So PET is an example of this. Some people like to call this depolymerization. Again, PET has been doing this for many years and commercially practiced. So popular examples of this are hydrolysis, glycolysis, methanolysis, and enzymatic hydrolysis. So some key points about chemical recycling is the molecules or monomers that you actually produce from chemical recycling are indistinguishable from those same monomers that came from fossil feedstocks. And most importantly is you can do this over and over again. So there's no limit. I mean, each time you're taking it back to those fundamental building blocks with zero degradation, and you can just keep doing it over and over again. And finally, all types of chemical recycling are necessary, but investments should only be made in technologies where the greenhouse gas footprint is lower than virgin. All right, we're going to do another interactive poll now that we've talked a little bit about chemical recycling. So let me switch back over to this. So keep your phone just how it was, and we're going to activate another poll, and you can answer. Let me move on here to this one. Okay, so this question is going to be, which idea best captures your thoughts around chemical recycling, now that I've talked about it a little bit? So here's your choices, A, B, C, D, or E. Starting with, my company is actively working on chemical recycling solutions, to chemical recycling isn't really recycling. We're anxious to hear your thoughts here. Looks like it's working, Jayme.
I already voted.
Glad to see some folks are already out there working on it. Great feedback. We'll give folks just a few more seconds here. Thanks everybody for participating. All right. Very good. So we'll let these votes keep coming in. Thank you. This is great feedback. And hopefully I'm going to talk a little bit more in detail about this and help some of these folks that may have concerns or don't have an opinion yet. All right. All righty, back to the slides here. All right, so as more and more people learn about the potentials of chemical recycling, the exciting possibilities seem evident. I think the industry has been slow to innovate up to this point, but this is no longer the case. So as they say, the mother of invention is necessity, and I believe the industry understands that we have to act now. So as plastic professionals, we need to promote and educate about the possibles of chemical recycling in our industry and beyond. Chemical recycling is still new and misunderstood, and it's being excluded from legislation as we speak. We have to change that if we're going to solve the plastic waste crisis. The alternative is to not ban plastics. The alternative is to figure out how to manage the waste problem through recycling. So at Eastman, we are almost singularly focused on this right now. It's becoming part of our DNA. If we want to truly live our brand of enhancing the quality of life in a material way, this has to be part of our story. So to bring this to life, I'm going to share a little bit about our circular solutions that we've launched in the past few months. So this is not intended to be an Eastman commercial, but instead show you what we're doing so you have some confidence that progress is being made in this area. Okay, so we have three major types of recycled technologies at Eastman today, but I'm only going to focus on the two on the right-hand side of the slide here. And we call these two chemical recycling technologies our advanced circular recycling technologies. We have two major types, two major classes. We have carbon renewal technology in the Navy, and then we have polyester renewal technology, or PRT. So let's talk about the CRT, the carbon renewal technology first. So you may or may not know, Eastman has been a pioneer in chemicals from coal technology since 1983, where we've turned fossil fuels straight into molecular carbon, hydrogen, and oxygen, and that's called syngas. And we've used that syngas to make into acetic anhydride, which then gets combined with renewably resourced cellulose from trees to create our specialty cellulosic portfolio that goes into fibers, textiles, and specialty plastics. So with a new twist on this old technology, we figured out how to feed waste plastic diverted from landfills directly into this process to make the same cellulosic polymers, but now with high levels of recycled plastic. We've been operating this since the end of 2019. Most exciting about this CRT technology is we can do it at 20 to 50% lower greenhouse gas emissions than from the coal itself. The other type of chemical recycling technology is our PRT, or polyester renewal technology. So this technology is mainly focused on PET, whereas the carbon renewal is a broad range of waste plastics. I'll talk about that in a second. The PRT is just focused on polyester or PET. We have two types. We have glycolysis and methanolysis. So glycolysis is using ethylene glycol to depolymerize PET. And we're actually doing that today, operating it today, ready to putting it into products as we speak. The other type is methanolysis, where you use methanol to depolymerize PET. So we're in the process of building that plant. It'll be operational by 2022. So the great thing about PRT is, like we could on the CRT with polyester renewal technology, we're able to do that at 20 to 30% lower greenhouse gas emissions than making that DMT or that ethylene glycol from fossil-based feedstocks. Okay. So some key points and takeaways regarding these two technologies. So we have launched commercial scale chemical recycling for a broad set of plastics that are currently being landfilled or worse, leaked into the environment. We're replacing fossil fuel feedstocks in our processes with plastic waste feedstocks. And we're doing it to produce a range of products that contain between 25 and 100% recycled content. So we're capable of processing between 30 and 50 million pounds of this waste in 2020. However, we plan to grow that number exponentially in the coming years. So we're just now getting started. So a fun fact, like I said, we started this towards the end of 2019. By February of 2020, in our CRT process, we have processed around 1.5 million pounds of waste plastic, and that is 3 times the amount of plastic collected in our hometown. So in 1 year. So we were able to process 3 times of that just by starting up in around November, December of 2019. So we're very excited about that. All right, let's dive a little bit deeper into each of the technologies. There's a few things that I hadn't shared that I'm real excited to talk about. So let's start with the CRT, or the carbon renewal. So again, this is operational now, and it breaks down a wide variety of plastics down to the molecular level. So it takes the plastic and reforms it down to carbon, oxygen, and hydrogen. As you can see on the left there, we can take RIC codes 1, 2, 4, 5, 6, and 7. You may notice that there's no 3 on there. We can't yet take in PVC because of what it does to metallurgy, but we're working on that. We've made investments to be able to fix that in the future. So again, this goes into our cellulosic plastics and acetyl chemicals. And we're able to get for between 20 and 100% recycled content. And again, we can do it at a 20 to 50% lower greenhouse gas emissions. Our second type is the polyester renewal technology. Again, it only focuses on PET, so you've got the RIC code 1 there. We've got 2 types. We've got the glycolysis, which is happening right now, and then methanolysis, which is coming in 2022. And in this case, we don't go all the way back to the molecules. We just unzip the polymer down to the DMT and ethylene glycol that are used to make PET in the first place. And those recycled products go into our copolyester specialty plastic stream. Things like Triton, Embrace, Cristal, our whole line of specialty plastics. And we can do that at 20 to 30% lower greenhouse gas emissions than if you were to make that DMT and ethylene glycol from fossil-based fuel feedstocks. Okay, so let's take you back to the slide that I showed you a second ago, where we talked about what can and cannot be mechanically recycled. Well, if you now take Eastman's chemical recycling technologies and overlay that on the slide, you can see we can cover the full gamut of plastics. So our polyester renewal technology, PRT, covers all the PET types, films, thermoforms, textiles, carpet. We can handle all of that. And then over on the CRT side, we can handle pretty much everything else except for the PVC. This is what we're so excited about, is having the ability to recycle all these types of waste plastics. So to sum it up, our advanced circular recycling technology enables waste diverted from landfills as a feedstock to make our products with lower greenhouse gas emissions right now. We're doing it at scale, we're doing it right now. So as you can see here, for example, if you were to purchase Eastman Triton Renew at 87% certified recycled content, you're actually pulling out 4,300 metric tons that would have been sent into a landfill to make that plastic, and you're reducing greenhouse gas around 10 to 14% versus virgin. And this is at the product level, and you're taking 6 to 9 million cars off the road by buying that product. So we're very excited about this, and very anxious to share it with the world. So let me finish with one last final thought and a challenge here. So when we look at a picture like this, somebody throwing away a bottle, we need to get to a point where we no longer see waste. Instead, we should see feedstock, or a valuable source of carbon to make into new chemicals and plastics. We should stop thinking about this as trash. There is value in that bottle. I want to encourage everyone on this broadcast to no longer think of single-use plastics as single-use. Plastics should never be a single-use material, even if they're in a single-use application. They should be kept in play and can be used over and over again. We truly have the opportunity to create a circular system in which we recover waste at scale, break it down to its building blocks, and make new products to care for 10 billion people. And we can do it over and over and over again. Thank you.
Great, Jayme, thank you so much. Wow, I feel we can divide your presentation into several subtopics and have several conferences about it. Connor Carlin is going to have a great afternoon, discussing subjects that you have brought up. While I give time to all of you to prepare your questions, let me start with a reflection on this. This is a conference about plastics, and most particularly plastics engineering. That is the making of objects that increase our quality of life using polymers, plastics, materials, and all technologies associated, that create these objects. And so I'm going to start with the last slide you presented, actually. And it's maybe a point of view. We don't have a plastics problem, as you said, or glass or aluminum or paper problem. It seems like mankind, humanity, has a waste management problem. And if I hear you well, so let me start with the last slide on feedstock. Collection of waste plastic feedstocks are challenging, right? And to fuel all these ambitious goals that you have. How do we go about it? New collection methods, new partnerships, with whom do we partner? How do we go about it, Jayme?
Yeah, great question, Jayme. So as you heard me say, we're on track to do 30 to 50 million pounds of waste plastic in 2020, but this is just the beginning. Our ultimate goals are well beyond that. And to get there, probably the thing that keeps me up most at night is the collection and aggregation of that feedstock. It's one of the biggest challenges as we tackle this plastic waste problem. So at Eastman, we've been incredibly busy on that front, forming partnerships, and we're just getting started. So one that I can talk about publicly is a partnership that we struck with a company called Circular Polymers out of California. So Circular Polymers collects and reclaims post-consumer carpet that's headed for landfills in California. So they take the carpet, they separate the PET fiber and densify it, and then ship it to Kingsport by rail. So we take that carpet, and that's one of the feeds that goes into our carbon renewal technology today, and it will eventually go into our polyester renewal technology. So through this partnership, we're planning on diverting millions of pounds of carpet from landfills just in the first year. So we're continuing to look for opportunities at this scale. And that's one of the reasons I've got my contact information at the bottom of each screen. We want to hear about your ideas for big things like this. So I'm going to make one more comment on that question. Is not only are we looking for these really big, what we call base load feedstock streams, we're also partnering with our customers to take back our own products. So there's also these what we call strategic takebacks. So we just announced a partnership with a company called Mazzucchelli 1849, and they're a world leader in the manufacture and distribution of acetate sheet for premium eyewear. So some folks out there may have sunglasses or reading glasses that are made out of acetate, really, really nice glasses. Well, in that process, the waste generated is upwards of 80%. If you think about cutting out the plastic for your frames and the temples, and a lot of waste is generated. So what we're doing is we made a partnership with Mazzucchelli, who supplies this industry. They buy acetate, cellulose diacetate from Eastman, and then they're shipping us back their waste. And we're grinding that and putting it into our process as well. So these are just a few examples of the partnerships. But we continue to pursue large, robust, and environmentally advantaged feedstock streams. So if you have any ideas, please reach out.
Right, Jayme, let's stay on waste for now. And a question that's coming from the audience is that of segregation and separation. For example, labels, adhesives that go, with the label, plastics that come intermingled, different layers and all that. How do we tackle that?
Yeah, so good question. So right now, up to this point, Eastman's been focused on developing the technologies to actually recycle this plastic, but of course it has to be in the right form. So for example, with Circular Polymers out of California, they help us get it into that form. So what I can say is we are thinking beyond that, and we are looking at options to collect, aggregate, separate, so that we can actually feed these plastics into our process. So, the best thing for us, the best feedstocks for us are going to be the ones that obviously are the cheapest or the most readily available. And collecting and separating are going to be very valuable. But also, we continue to develop our technologies, so you don't have to do that. So, in our goal, a big win is if we can continue to develop recycling technologies that can take a very wide range of feeds.
Well, one of the problems that we understand and that we see with mechanical recycling is the fact of contamination, particularly for food, right? Is that also an issue with the chemical recycling?
Good question. So we are a chemical plant, and we are using our existing processes today to take these recycled feedstocks and send them through. So the reality of that is, in a chemical plant, we've already got unit operations and processes that separate all of what you might consider bad or contaminants. So when we design and build our methanolysis plant or our CRT, any contaminants that come in, they have their place, and they're being segregated and being taken care of. So we're not worried about that.
Jayme, let's talk about CRT, because I'm flooded with questions about CRT. So the first one and the most simple one is, can you further explain how CRT will help remove a number of cars off the road?
Because when you bring a waste plastic in and you are putting it through our CRT process, if you think about plastic, so in the CRT process, you're actually processing plastic instead of the original feedstock, which is coal. And coal's actually coming out of the ground, so it's actually pretty dirty. Whereas the plastic that we're producing, plastic is in essence, a very organized systematic arrangement of molecules. So those molecules actually process in our technology a lot more efficiently. So they don't take as much greenhouse gas emissions as they go through the entire process from breaking it down to the molecules to making the final product. So we're able to do that with less energy overall versus the coal. And when you do that, that we just, it's ultimately a greenhouse gas reduction. And once you have the greenhouse gas reduction, you can put it in terms of any type of carbon savings. In this case, cars.
So there is waste, byproducts of the CRT process,
just like there is whenever we process the coal. There's always a waste stream there that is as you purify those products. But yes, it's whenever you're doing plastic, there's actually less than there is with the coal.
So with carbon renewal technology, you can recycle pretty much all kind of plastics. So why do you need the polyester renewal technology then?
Great question. So we're recycling waste plastic, so we can offer certified recycled content in both of our major product streams, both our acetyl product portfolio and our copolyester product portfolio. And those two technologies get us to those two front-end product portfolios. So the carbon renewal technology generates recycled content only for our acetate or acetyl product portfolio. So those are things like your cellulose-based products for fibers, textiles, coatings, and inks, and performance plastics. And then the polyester renewal technology generates recycled content for a wide range of specialty copolyesters and modified PET. So you've got two different recycling technologies for 7 different plastic waste streams, serving 2 different product portfolios.
I'm going to open a can of worms. I'm going to get into politics. How about that? How about that for being live? Now, this is great statistics, great information, and of course, the word that we keep on hearing is education. You need to tell people, what it is, how it works, and all that. How can you be certain that legislators, NGOs, and all other people that love just giving, likes in, all these social platforms, that they get the points and the benefits that you are making?
So that's a great point. And at Eastman, as we've stood up this effort to go after the plastic waste problem, we have absolutely not ignored that. So a big part of our company is focused on that advocacy. So we've got government affairs folks going out, talking to legislators, partnering with the Ellen MacArthur Foundation, also out there talking and influencing in the world. So we're not just out there promoting our own chemical recycling technologies. We think it's important that all of chemical recycling, as long as it has lower greenhouse gas emissions and its material to material solution, are important. So we're partnering where we can to go out and do the advocacy. It's a great point. I mean, we're definitely dedicated to solving that together with other folks.
You said something that was quite important. I said, we have to get out of our mind that this is single use. There is a lot of value. There is fuel in this, material, in this object, right? Just like there is with aluminum or steel cans or, alternate, feedstock. So how do we pass on the message to these NGOs and politicians and all that, that, hey, this is not waste, this is fuel?
Yeah, there's, I think the number, Ellen MacArthur Foundation may have estimated $80 billion in value in plastics that are just going into the ground or being incinerated. So, if folks go out and start to learn about the circular economy, these types of things are talked about. There's actually a huge economic benefit for the world to start taking this waste that we're just putting into the ground and finding the value out of it. And I think that starts with these, making plastic valuable so that people know to recycle it, and they know to put it in the recycle bin, and they join programs, and local municipalities have programs, and maybe there's a national bill that gets going, that makes recycling very, very valuable and gives people the incentive to do it. But this is not just Eastman in this. This is the whole plastics industry. We need to all work together to do that, and we can't do it alone.
Jayme, you're talking your presentation. It seems to be oriented towards landscape and the proper disposal and chemical recycling and all that is great and fantastic. But when you look at the pictures of what's coming on at television and everybody commenting and all that, they seem to be focused in the ocean, right? That for whatever reason that's worried, and then you get the turtles with the straw right through their noses, and everybody's So how do you see this public perception that is driven mostly by what I just described? How do you deal with it when you're talking about plastic as waste, as fuel, or incineration?
Yeah, the plastics in the ocean is certainly a leading topic. So our CRT technology is uniquely positioned such that we could process waste from the ocean. We can actually do that. However, there's a much larger, more reliable, more environmentally advantaged stream well upstream of that, well upstream of the plastics in the ocean. So we want to stop it before it even gets to the ocean. But with that said, we're not ruling out ocean plastics. There's just so much more of it before it gets there that's actually more readily available. So I would say that Eastman is certainly, we're seeking a credible and proven ocean cleanup organization to pilot something like that. We would be glad to do it. But remember, we're pretty firm on this. If we're going to do that, it must be carbon neutral versus virgin feedstock. So we're not going to participate in something where you have to go out and get all this plastic out of the ocean. You end up creating more greenhouse gas by doing that than you did by not doing it. So sort of our criteria there.
Just to piggyback on what you're just saying, how do we compare then again from the cost perspective, renew products to traditional feedstock materials? At what point does an equilibrium, there is a business model, financially makes sense? Any opinions on that?
Yeah, I mean, solving the plastic waste crisis is not going to be free. So we're all going to have to take on that extra cost across the value chain. As a work, we know these are more expensive to collect and aggregate and process it through the process. But we're very confident that the industry and the market sees that and they get it. And we also think that consumers are willing to pay for that. I think that this issue has gotten big enough that there's value in solving it.
Jayme, one advantage I see on the mechanical recycling resides in the fact that the equipment has a small footprint. However, when you start talking about chemical recycling, it requires a huge chemical plant. Any comments on that subject?
Really good question. So, keep in mind, with the exception of some small facilities to bring in the waste plastic and to get it into the right form that we needed it to get it into, we're using existing chemical processes that we already have in the ground today to do this. So whenever we do calculate a life cycle analysis, whenever we assess the greenhouse gas emissions, we absolutely we take into account from where we get that plastic. When it's in a landfill, the waste or the GHG is 0, but we have to account, whatever processing you need to do, traveling to Kingsport, getting it here, we actually take that into account. Even so, with that said, even when we build our methanolysis plant, our new methanolysis plant that's going to take the polyester and break it down to the DMT and EG, we will be we will actually be doing that at a lower greenhouse gas emissions than the virgin material.
I have 2 more questions, and actually it's a comment and a question. The comment, because you already answered the question, it was related to oil prices and influence that these very low oil prices, have on chemical recycling. But you already mentioned it, and here we are meeting, virtually for a reason. it seems like, the new models going forward are not necessarily related to making money. We have to do them because it's the right thing to do for the planet, for mankind, for us. So, whether the oil price goes down to 20 a barrel or whatever, and it makes a recycled material expensive, still, is morally the right thing to do, to implement it. You want to close, last comment on that?
No, I definitely think that the younger generations coming up see and feel and understand the plastic waste crisis, and it just keeps getting more and more attention. I think that regardless of cost, the industry and the state of the world is such that it's time to fix this, and I think people are motivated to do it. And not only that, I mean, look at the data. Look at these major brands and retailers making these major commitments. So I think it's becoming a brand image thing with these big companies, and that's to me the biggest data point that says this is here to stay. This is real. Is Procter's and Gamble's and the Nestle's and Cokes and Pepsi's. I mean, they're very, very much invested in this because they know the consumer wants to make the right choice. So, oil being where it's at, we're not scared here at Eastman. We're still working hard on this.
Okay. The very last question is: will you make the results of the poll available?
Yep. Be glad to.
Okay. Very good. Well, Jayme, thank you so much. This was a very interesting presentation. And of course, as I've done with all the speakers, here's our virtual applause.
Thank you, Jayme.